All right, let's review for this test. First question is an exponential graph function. If we look at this number in the parentheses, you should know it's a decay because that is less than 1. So if you look at the graph, you see how it's decaying. That's a good starting point. Next thing you want to look at is this number right here, because this is the asymptote, the horizontal asymptote. Normally an exponential decay goes up against the x-axis. But since it has -6, meaning it's been pushed down 6, the horizontal asymptote is now at -6. Watch carefully. See, I went by 2s, just so you know. That's why that's -6 down here. So if you want to look for the horizontal asymptote, and you want to look right here to give you an idea if it's a growth or decay. And we know a value is positive, so we know it's above the horizontal asymptote. If your a value was negative, it would be underneath. It would have been a flipped exponential decay. So it would be like this graph, and it would look like that if that was a -8, but it's not. All right, now we want to find some dots. We want at least 2 dots to make a nice clean graph. Normally we just put in 0 and 1, but because of this, you put 0 and 1 in, it might not come out nice. So it's a lot better if you try to make this equal to 0. That's what I did here. So what minus 2 equals 0? 2. So I'm going to plug in 2, not 0. So when I plug in 2, see I plugged in 2 right there, that becomes 0. Anything to the 0 is 1, so 8 times 1 is 8 divided by -6 is 2. Do you see the coordinate 2, 2? There's a dot. Next one, why did I choose 3? Well, normally you want to put 0 and 1 is this next easiest number. So if I want to get this to become a 1, 3 would do that. See right here? When I plug in 3, all right, you'd get 1. Now, interesting thing, I forgot to put the -6 here. There we go. I just forgot that. It's kind of interesting because it's from right here. All right, so what we do here now, that becomes a 1. Then 1/4 of the first is just 1/4. So 8 divided by 4 is 2. 2 minus 6 is -4. Now we go to the coordinate 3, -4. Over 3, down 4. And connect the dots, there it goes. Remember, we knew it was a decay graph through those dots and goes up against this horizontal asymptote. All right, for this next graph, we are going to graph a logarithm. It's base 5. It has a -3a value. So it's -3 means it's going to be upside down. All right, a normal logarithm usually goes like that. But since it's negative, that's why you can see it's upside down. A logarithm always has a vertical asymptote. Normally, it's right here. But since it's been shifted to the left 4, a positive 4, opposite is -4. So we went left 4, so the asymptote got shifted left 4. So 2 key things are looking at this to see how the asymptote gets shifted horizontally. And look at this to think about, is it flipped or not? Don't worry about the number. That's how wide or narrow it is, which we're not going to talk about vertical stretches and shrink with graph. That's why I got the dots. The dots will help us get the best sketch. So what we're going to do here is we have to choose 2 values. Now, why did I choose these 2 values? Well, when you graph a log, the cleanest, nicest numbers to plug in are 1 and the base. See, that's the base. You want to get 1 and the base. Now, the problem is, with this here, you can't just plug in 1 all the time because it doesn't create a nice number all the time. So I want this to equal 1 because if this is 5 to the what power is 1, that would equal 0. So again, starting over, you want this to equal 1 and you want to equal this equal to the base. Otherwise, you get really ugly numbers. So what I want to equal 1, there's my equation. I minus the 4 over, so -3. I also want this to equal the base, 5, minus the 4 equal 1. So these are the 2 numbers I'm going to plug in. And as you can see over here, they come out really nice. When you plug this in, you get 1. 5 to the what power is 1, that's 0. And then that will be 0 plus 2 is 2. -3, 2. There's the coordinate. This one, you plug in the 1. 1 plus 4 is 5. 5 to the what power is 5, that's 1. -3 times 1 is -3, plus 2 is -1. That's 1, -1. There's my 2 dots. And as I said earlier, you have your asymptote, and you know it will go like this because of the -a value. Again, be very careful what numbers you plug in. If you just choose whatever you want, It might be complicated. You still can graph with other numbers. It just makes it a lot harder. Alrighty, for this next problem, we're going to solve this. But our answers are going to look like one of these. So let me show you how that works. Basically, this is all ready to solve. So what we have to do is put the word log in front and switch the x and the 8/7. See right here? Put the word log in front. The 8/7 is what the inside the log. The 3 is the base, and the x. We switched those two. And so we got x equals. That's all we did to solve. We just changed it to a log. Done. Now the problem is it's not going to look like this on the test. It's multiple choice. So you have to manipulate it. So there's something called change of base. You are allowed to take any log, and you can write it as log of this over log of the base. So I have log of what's inside the log and over log of the base. Now, that still doesn't match either of these, but what you now notice is you should know how to expand this. All right, 8 divided by 7, whenever you have a divide inside of a log, that means minus. So there's the answer. So be very careful on the test. You have to be able to expand and change the base to spread it out. It's not just going to be this on one of your problems. Some problems, this is fine. But some you have to change to like this. Now, what the heck is this answer? Well, technically, when you do this change of base thing, when you take it and make it a 2 separate logs, you could have done ln top and ln bottom. It doesn't have to be log. You can do log or ln. So you can see these are exactly the same except for log versus ln. So just beware, it could be both. All right, this next one, you're going to write a function with a vertical shrink of 1/2. By the way, here's the function you're dealing with. Translate 2 units to the left and 1 unit up. So here's our log base 5x. It says it's shrinking by 1/2, so that's the number in front, that's the a. Right here is the left to right movement. So this is going left 2. So if it's going this way, well, that's a negative movement, and we always do opposites of the inside the parenthesis next to the x, so that's an opposite. And then we're going up 1 unit up. So up is your k, which is not opposite. So there is the equation we're looking for. All right, the next part here is we are going to write an equation for this graph. Now we should know it, since there's a vertical asymptote, we should know it's a log. Second of all, we also want to look at this asymptote. It's at positive 2, sorry. Since the asymptote is at positive 2, normally the asymptote's right here, so we know it got pushed right 2. Now, horizontal shifts are the x, so we went right 2. Now, why is that a negative 2? Because it's always opposite. So since it went positive 2 this way, you do opposite, that's a negative 2. So we want an answer that has a positive 2 right shift. We don't really care about the base, that's really hard to tell. We don't really care about the a value, we just should know it's positive, that's key, it's positive. But we don't know the exact a value, we don't know the base. It's more important to be looking for this right here. This is the most important thing for writing an equation because this is a multiple choice question. So now how did I get this part? Well, don't you remember that logs always have the point 1, 0? Okay, they always have the dot 1, 0. So if you look at this coordinate down here, isn't that going over 2 and down 3? Well, isn't this saying go right 2 and down 3? Isn't that what the shift means? So that's kind of how I manipulated that. You have to realize there's always a 1, 0, and it got shifted for that dot. Now, we don't know this is the exact equation again, but this is a possible equation. And when you do the problem on the test, look carefully at this and look carefully at this, but this is the key to it all. And again, make sure it's not a negative in front. A negative would go like this. So, hope that helps. All right, we're going to expand this log. So to expand a log, well, the two things inside are 9 and c cubed. That's 9 times c cubed, so a times is a plus. So do you see right here? We separated both base 6, a 9 and a c cubed. Where'd the cube go? Well, you should remember that cubes jump in front. Any powers go in front of the log. So I kind of did 2 parts in that problem. Sorry about that. But again, the key is when you multiply, it's a plus. If it was a divide, it'd be a minus. And again, any powers go into the front. this problem, we're just going to rewrite, and this is a log. So you put the word log right here and switch these two. So there it is. 3 to the what power is 81? Is it 3 to the 4th is 81? Why, yes, it is. Now, be very careful on this test. I think this is a free response question, and it's very important that the 81 is in the log level. Think of it as a line underneath there, and the base is lowered. If you write this where like the 81's raised and the 3 is kind of higher, you could be wrong. And so I'm very picky about it's log 81 with a base of 3 equaling 4. This last one down here, number 8, next one, sorry, not last. I want to evaluate this value. So there's different ways of doing it. The first way I did it here, if you can look, I expanded it out. 1 divided by 36 is 1 minus 36. And then the value of this is 6 to the what power is 1, that's 0. This is saying 6 to the what power is 36, that's 2. 0 minus 2 is negative 2. Another way, again there's multiple ways of doing this, is you should notice this as 36 to the negative first. Because anytime a number's 1 over, you can just say it's that to the like negative first power. Okay, then I can take the negative 1, bring it out front, and then 6 to the what power is 36? 2. And the negative, so negative 1 times 2 is negative 2. There are other ways of doing it too. You can try different ways, but the key is just kind of breaking it down using expanding or whatever you need to find the value of it. You could also think 6 to the what power is 1 over 36. You could actually, if you're really good at looking at it, know it would be 6 to the negative second is 1 over 36. But that is a little hard for a lot of people to see. Now, we're going to solve for x. So we're going to get this x by itself. Now realize that 8 is not in the power, that's lower. So the first step is minus the 8 over, because we're doing PEMDAS backwards. So we add or subtract things off first. So we minus it over, we get this. Now you might also notice I switched the z to the 6x on the left and have this on the right. You're allowed to do it. It's called the reflexive property. Because when I write logs, it's really important to have the exponent on the left. It just kind of makes it easier for me. If you can do it with this on the right and the y minus 8 over here, go for it. I just think it's easier to have the exponent on the left. Because the next step now, you put the word log on and switch this and this. So I put the word log on and I switch those two. Switch. So there I am. But I'm not done yet. I get the 6 off. To get rid of the 6 off, you divide it off. So you divide this by 6, and it's just this ugly thing divided by 6. That is the answer. It's really ugly, and you're just rewriting and moving things around. Number 10 here, I'm going to find the value. Evaluate means find the value. So this is saying 3 to the what power is 81. You might struggle with that, but it is 4. 3 to the 4th is 81. This is saying 2 to the what power is 2. That would be first. And this is saying 5 to the what power is 25. 5 to the what power is 25. That would be 2. So 4 minus 1 is 3. 3 minus 2 is 1. So all that would be 1. Now be careful. On this problem, you cannot combine these. Why can you not condense? It's called condensing. These logs is look at the bases. Each base is different. So do not try to condense them when the bases are different. Find each one individually. Now you can condense if the bases are the same. That would be like this one down here in a little bit. All right, so let's solve this equation. To solve this equation, I have exponents on both sides. So we're not going to use logs on this one. We want to get the bases the same. Now this might be a little tricky at first, but what you realize is I can't change 27 to be 9. I can't change 9 to be 27 without some really big changes. So what I'm going to do here is I am going to make these smaller. What I notice is this is really 3 squared, and this is 3 to the 3rd. Again, the key is to get the same base. So if that's 3 squared and that's 3 cubed, those are legal just ways of changing it. And then, so the bases are the same now. Okay? When you take a power to a power, you multiply. It's called distributive property. So 2 times 5x is 10x. 2 times negative 1 is negative 2. 3 times 1 is 3. 3 times negative x is negative 3x. The bases are the same. So with the bases the same, we can now just set the powers equal and solve. As long as the bases are the same. You cannot do that until you have the bases the same. Now we're solving. So looks like I added the 3x this way, and I added the 2 this way, and then I divide by 13, and there is my answer, 5/13. And you could plug it in and check, but that'd be kind of annoying. It's kind of ugly to check. Alrighty, number 12. I want to express this as a single logarithm. That means condense. The bases are the same, so I can. But before I start condensing, I first want to take these numbers in front and make them powers. So you can see right there, that becomes 5 squared. That becomes 4 to the third. 5 squared is 25. 4 to the third is 64. And a minus means divide. So you have the log, and again it was 25 divided by 64. 64, 25, divide. And that is called condensing. Next one, we're going to find the inverse. The inverse means to solve for, you want to first, for an inverse, switch x and y. You see how I did that there in the blue? And then we're going to solve for y. So, I switched x and y. I'm solving for y. So first step is I got to get this exponent part by itself, so I divide by -3. And then I switched the sides, called reflexive properly. I switched these sides. Then I put the word log in front and switched this and this. See, I put in the green, put the word log right here. I switched this and this. And then in red, you can notice I'm now trying to get y by itself, so I'm minusing 8 over. And when I minus 8, I just put -8 plus that. You could also put the -8 behind. Just be careful you don't kind of get that inside, because those parentheses are really important. I like to put it in front, but again, make sure you don't put -8 times that. Make sure it's plus there. Now, how do you get rid of that negative left? So you have the negative y still left. I have to divide by -1. And when I divide by -1, be careful, -1 does simplify. If that, say that was -4 or -6, you wouldn't simplify. You just let it be on the bottom. But since it's -1, it divides this, giving you a +8, divides this, giving you a negative. So watch out. With the -1, there is that last step that can really mess you up. And we got y equals. This is called the inverse of that function. Last problem. Given this function, kind of z of x, it's kind of interesting. We're going to use z of x for a while. But we're going to, given this logarithmic function, describe how the graph is transformed of its parent's graph. So the first thing is, let's look at the -4. -4 is a flip because it's negative and has a vertical stretch by a factor of 4. So we know this is going to flip and have a stretch by a factor of 4. All right, what does this tell us? Well, this told us we're going to shift 5, +5, because the opposite of -5. So that would be right 5, so we're going this way. And this part tells you to go down 7. That is the transformation of it. Now, if you thought about what this looks like, just for practicing, this would be an upside down, and it would have a vertical asymptote at 5. But it would be upside down.